Hi, my name is Sophie, and I'm narrating Cheryl Li's lesson on significant figures, and this is her first lesson on general chemistry. So what are sig figs and why do they matter? Sig figs are numbers used in rounding, and they're based off of a measuring tool, and it shows how precise a measurement is. More significant figures is equal to more precise of a measurement. So how do we calculate measurements with sig figs from a measuring device? Certain digits are marked by tick marks on the instrument. Uncertain digits, which are not marked by tick marks, are usually eyeballed. And we normally round measurement to the uncertain digit, which is one decimal place more than the last precise digit. So here are some examples of rounding measurements based off of sig figs. In the first example, you can see that the ones place is the certain digit, and the tenths place is the uncertain digit. So by eyeballing it, you can see that it's probably around 2.3. In the second example, the ones place is once again the certain digit. The tenths place is also a certain digit, since you can see there's more tick marks on that measuring device. And the hundredths place is the uncertain digit. So you can say this is about 3.65. Here is the first rule for significant figures. All real numbers are significant and each counts as one sig fig. For example, 1, 2, 3, 4, 5, 6, on and on, those all count as sig figs since they're real numbers. Here's the example. 125.6 counts as 4 sig figs. So let's do some practice with the first rule. Feel free to pause the video and try to cover up the answers and do some practice by yourself. I'll read off a few examples and answers. For example, the number 11 would be 2 sig figs, number 13.4 would be 3 sig figs, and number 3199 would be 4 sig figs. Next up, we have the rule of zeros for sig figs. If the zero is in the middle, it's always considered significant. So you do count it. Such as the number 105, where the zero is in the middle, we say that is 3 sig figs. However, if the zero is the beginning, such as the number 0.025, that number 0 is not significant. So once again, to the example 0.025, it only is 2 sig figs. Now, if the 0 as the end, it only counts as significant if it's a decimal. For example, the number 1000 is only 1 sig fig because there's no decimal point, but the number 1000.00 with the decimal point would be 6 sig figs. Here's some practice for the zeros rule. If you want some practice, please cover up the answers and try to figure them out on your own. If you need some help, rewind the video and rewatch to relearn the rules. The exponent rule for significant figures is that the exponents do not count as sig figs. For example, 1.2 times 10 to the power of 10 only counts as 2 sig figs, not 12. And you can see this is because when you multiply it out, all the zeros at the end ultimately do not count. Here's some practice for the exponent rule. I'll just read off a few. For example, 10.4 to the power times 10 to the power of 19 is 3 sig figs. 9.291 times 10 to the power of 2 is 4 sig figs. Then we have the addition and subtraction of numbers with regards to sig figs. For this, you have to round to the least amount of significant figures after the decimal. For example, the number 0.085 is 2 sig figs since you're rounding to the least amount of significant figures after decimal, which is you're counting the 8 and the 5. And you're adding that to 0.06, which is 1 sig fig. And you're adding that to 0.14, which is 2 sig figs. And that adds up to, if you just do the normal addition with the numbers, that adds up to 0.285, which is about 0.3, which is 1 sig fig. And the example down below is 12 plus 16.25 plus 15.0, and that adds up to 43.25, which rounds to 43. And you can count the sig figs for that as well, which is 2 sig figs. Then we have multiplication and division of numbers with regards to sig figs. For this, you round to the least total amount of sig figs in the problem. For example, 4.5 is 2 sig figs times 1.25, which is 3 sig figs, is equal to 5.625, which is about 5.6. And here's some operation practice with regards to sig figs. and you can pause the video and cover up the answers if you want to practice. And I'll repeat it once again. You can always pause the video, rewind, or do anything like that to try to relearn if there's anything that happens to be unclear. Alright, so that's it for today's lecture. Thank you so much for coming. And once again, thank you, Cheryl, for sending this video. I hope I did a okay job narrating it. And if you have any specific questions, please email it to stem.scholars.foundation@gmail.com. And we hope to see you in the next lecture. Thank you.